Hi guys, this is Sir Eldon Calamba. So this is another discussion before our sample problem. So let's start. So hi. So we now have velocity versus time graph na naman. So it's kinda different with our position versus time graph. Our velocity versus time graph is nabago lang sa ating vertical axis. Ang vertical axis natin ngayon, it should be in velocity. Naka-SI unit ako, it should be in meters per second, and my time should be in seconds. Now, by inspection, um, si velocity versus time graph is it tells me kung paano nag-change ang aking velocity throughout time. As you can see, from 0 second to, let's say, to 7 second. From 0 meters per second na 0 at 0 second, after 7 seconds, naging 4 meters per second siya. Okay? So, it tells me na it is a speeding up. It is a moving faster. But, ibang usapan if makita mo dito from 6 seconds to 10 seconds. So, from 6 seconds to 10 seconds. Just because na pababa ang slope na ating nakikita is that nag-slow down ang ating object or ating particle. No. Okay? Velocity, it talks about the change in direction also. So, we have to do inspection. We have to put into our mind na it does not mean na if it is going down, slowing down kaagad, or if it's going up, speeding up kaagad. Iba-iba ito. Okay? So, let's have the idea of the slope again. The slope this time for a velocity versus time graph. Okay, slope. Pa-inspection tayo ha. So, slope. So, slope is just equal to rise over run. Iba ang rise natin. Hindi ngayon ito x. It is in terms of velocity. So, there is that change in velocity that is just v2 minus v1 over t2 minus t1. Meaning to say, gaano ba kabilis nag-change ang velocity ko with respect to time? So, dapat makikita mo dito nga na ngayon na gaano kabilis mag-change ang velocity ko. So, I should be talking about the acceleration this time. So, meaning to say, ang slope ko is just equal to an acceleration. This time, average acceleration. That is just equal to delta V over delta T. Delta V over delta T. Sa X tayo lahat. So, alam natin ang direction dito. Okay? So, and acceleration tells you na acceleration could have positive and negative na values as you have read in chapter 2. Okay? And positive na acceleration, it does not tell you na speeding up kaagad. And if negative ang acceleration, is slowing down kaagad. You have to take a look at it na by pair. If positive ang ating velocity, tapos positive ang acceleration, dyan mo palang masasabi na, my particle should be speeding up towards the positive x direction. Pero, if you have a negative velocity, tapos negative din acceleration, speeding up din yun siya. Pero, it is moving towards the negative x direction. See, nakita mo ngayon na, if negative x pala na acceleration, or negative ang acceleration ko is, hindi pala kaagad slowing down. So, kailan siya mag-slow down? So, if you have a positive acceleration, pero negative ang velocity natin, that's the time that you have a particle that is slowing down. Or if you have a positive na velocity tapos negative ang acceleration, that's the time also na slowing down. Okay, so for this, you have our average acceleration that is just delta V over delta T. Now, we also have the instantaneous acceleration. For the instantaneous acceleration, actually the same with our velocity ginawa. The slope of our tangent line. So, instantaneous acceleration is just equal to delta V over delta T. The limit delta T is approaching 0. Or instantaneous velocity is, walang T, is just equal to dV over dt. Okay, so if titingnan ko ito ngayon, mag-ano lang ako, mag-summarize lang muna. So, if I have an average velocity, VAV, is just equal to delta x over delta t. V instantaneous, that is the limit delta t approaching 0. So, delta x over delta t, or this is dx over dt. Acceleration, average acceleration, this is just delta v over delta t. Instantaneous acceleration, this is just the limit delta t approaching 0. So delta v over delta t, or this is dv over dt. And the unit for our acceleration, delta v over delta t, or v over t, that's just meters per second or meters per second squared. That's our SI unit. Okay, so that's for our first information about our velocity versus time graph. Now, the slope, the velocity versus time graph will not just be focusing on the slope. Actually, velocity versus time graph is the most versatile graph because it gives you two information. It gives you also the displacement of your particle in a given time period. So let's say, for example, from 0 second to 7 seconds, if we want to get the displacement, we just have to get the area under the curve. So, papunta kay 7 seconds. So, kunin mo lang ang area na yan. And that area will give you the displacement. So, sulat ko lang dito. Area under the curve will give you the displacement in a given time area, in a given time interval. So, for example, from 0 second to 7 second, ang area na yan, actually, that is just a triangle. So, area natin is 1/2 base times height. So, this is just 1/2 times base, that's 7 seconds, times the height, that's 4 meters per second. So, 4 divided by 2 times 7. So, you have 14. So, you have 14 meters. Mag-cancel out si seconds. Okay? Kasi nga, seconds times meters per second. So, you have displacement of 14 meters. Okay? So, area under the curve of velocity versus time graph will give us the displacement in that given time interval. So, if you want from 0 seconds to 16 seconds, then you have to get the different area. So, area 1, etong dito, if you want, area 1. Tapos, eto, area 2 ka na naman. Area 2. Tapos, eto, area 3 if you want. Tapos, eto, area 4. Oh. Tapos, eto dito, area 5. So, if you want to get the total displacement, so you have to add all the area. Area 1 plus area 2 plus area 3 plus area 4 plus area 5. Okay? So, that's for our velocity versus time graph.